The objective of this session to solve some of the problems on powers. Now here I have taken this problem from Vivandari's book. So if you have a notebook and pen, you can note down. I am going to read the problem statement. Now here I am going to read it. Machine wise has a single start square threads with 24 mm nominal diameter and 5 mm pitch. You can refer this figure. The outer and inner diameters of the friction collar are 55 mm and 45 mm respectively. The coefficient of friction for thread surface and collar are 0.15 and 0.17 respectively. The machinist can comfortably exert a force of 150 Newton on the handle at a mean radius on 150 mm. That means to rotate this handle, how much is the force exerted? 150 Newton. Then second, how much is the handle length? That is 150 mm. It's shown in figure also, and it is mentioned in statement also. Assuming uniform wear for the collar, calculate the clamping force developed between the jaws. You know very well, for a machine jaw or a vice, there are two jaws. One is the fixed, second one is the moving. In between, we are holding the workpiece, and this is the part I would like to show. This part is the nut, and this part is a screw. And using this handle, we can exert the force, and we can rotate this handle. Because of this, screw moves towards the left or moves towards the right, or it's a movable jaw. And here we can hold the workpiece, okay, for doing some operation on it. Again, interesting thing in design, what you have to do, read always problem statement carefully. You can take 1 minute time. So what is given? Machine wise as a single start thread, form of thread is a square, nominal diameter D is equal to 24 mm, pitch P is equal to 5 mm. Then outer and inner diameter for friction collar. Collar diameters are given in this case. That means D or capital D was suffix and capital D I. Inner diameter 45, and these dimensions are required to find out the or to determine the torque required to overcome the collar friction. According to wear, again here it is assume uniform wear theory to find out this MTC. Then coefficient of friction for thread surface is given 0.15, 0.17 is given for collar. And based on this data, you have to solve the problem. The first step, what you have to do, always write the given data. Read problem statement carefully and write the given data. Now in this problem, for a screw, nominal diameter D, 24 mm is given, then pitch is given 5, and it's a single start thread. For a single start thread, you know very well lead is equal to pitch, so you can note down lead is equal to pitch 5 mm. Then for a screw, coefficient of friction 0.15. Then again for a collar, outer diameter of the collar is given 55 mm, inner diameter 45 mm, and coefficient of friction for a collar, that is 0.17 is given. And for a handle, to exert a force to rotate the screw, the force that is 150 Newton is given, the length of the handle 150 Newton. Okay, so now let us start how to solve the problem. How to solve the problem. Now therefore, first of all, you know very well, in first session we have seen what is DM. DM is equal to main diameter is equal to nominal diameter minus 0.55 P, and it is for a square thread. By using this expression, nominal diameter you can substitute 24, pitch is given 5, you will get DM is equal to 21.5 mm. Then we know that this relation tan alpha or helix angle or lead angle is equal to L upon pi DM. What is lead? Lead is equal to pitch for single start thread. And DM we have calculated 21.5. You can substitute all this value. So you will get tan alpha is equal to, and therefore alpha is equal to. So you will get this helix angle or lead angle. And once you know this, the next step you have to find out the phi. This is friction angle. Tan phi is equal to mu. Mu is the coefficient of friction for a screw or a thread surface, that is 0.15. So you can substitute here 15. The phi is equal to tan inverse of this 0.15. So you will get phi is equal to friction angle 8.531 degree. Remember these things. I hope you have got it. You have got it. Okay. Then once you know the mean diameter, once you know the alpha, that is helix angle, and once you know the friction angle, then what we have to do? We have to, in the problem statement, what is mentioned, once again I will tell you. Here, find out the clamping force. Clamping force means how much is the W required. Again here, you know, this force W required, because by rotating this screw, we are exerting some force, and that is the W. That we have to find out W. That we have to find out W. Okay. Then next, let us see. Torque required to raise the load. Torque required to raise the load. We know very well this expression. Mt is equal to W into dm by 2 into tan of 5 plus alpha. What is W? We don't know, that we have to find. What is Mt? That we have to find out. Dm is the mean diameter, that we have determined. Then phi and alpha we have also calculated. You can substitute all this value. You will get Mt is equal to 2.34 W. That means torque required to raise the load in terms of W. And this is for screw, considering only thread contact, remember. Then what you have to do in next step, again you have to find out torque required to overcome the collar friction, and for that purpose it is mentioned to use uniform wear theory. According to uniform wear theory, MTC is equal to mu c. So what you have to do to find out the torque required to overcome the collar friction, we have to use uniform wear theory. If it is not mentioned in problem also, always you have to prepare uniform wear theory. Yesterday we have discussed this thing. According to this theory, mu c W by 4 dO plus di. dO is given, di is given, that is 55, 35, mu c is given 0.17. So you can, what you have to find out? You have to find out the MTC in terms of W. Again, now you have a torque required to overcome the collar friction, torque required to overcome the thread friction. Then what you have to do? You can write MTT, means total torque, is equal to MT for thread plus MT for collar. But what is MTT? Total torque. Again, here in the problem statement, it is mentioned total external torque applied to the handle is 150 Newton is the force and distance 150. So here you will get the total torque 150 by 50. So it's your total torque. You can substitute here. So check it how it is solved. So on next slide, I have mentioned here the same thing. Here the MT total is equal to MT thread plus MT collar. MT thread means torque required to overcome the thread friction. MTC means torque required to overcome the collar friction. But what is MTT? This is M 150 into 150. It's a force exerted by the machinist, that is 150 Newton. And how much is the radius? That is 150. That's why you will get the total torque. MTT in terms of W 2.34 W. MTC in terms of 4.25 W. So by solving this equation, you will get the W. This is the clamping force. W is equal to 3414 Newton. Remember these things. In this way, you have to find out the clamping force developed between the joints. And next bit, it is asked in this problem, that is to find out the overall efficiency. Again, for overall efficiency, it's very simple. What you have to do? Overall efficiency is equal to work output upon work input. Yesterday, we have discussed this. What is the work output? Work output is equal to total torque MTT into 2 phi. And what is the work? Work output means this W into L. That means load to be lifted by how much distance, that is lead. Okay. And what is work input? That is torque into angle turn through. This is total torque into 2 pi. It's a input, and W into L is the output. So therefore, overall efficiency WL by 2 pi into MTT. So what is W? We have calculated this value L. This is lead by 2 pi means 3.14, mt means total torque, that is 150 into 150. You will get overall efficiency. The overall efficiency of the power screw is equal to 0.120 or 12%. Remember these things. It's a 12%. I hope you got it. Yes or no? If yes, you can put in chat box yes. Let us see one another problem. It's also a simple one. We will see second problem. You can note down this. I am going to read it. Lead screw. Always read problem statement carefully before solving it. The lead screw of a lathe has a single start isometric trapezoidal thread of 52 mm nominal diameter and 8 mm pitch. Screw is required to exert axial force of 2 kilonewton. How much force is exerted? 2 kilonewton. In order to drive the tool carriage during turning operation, it's a lead screw of a lathe made up of trapezoidal thread. Thrust is carried on the collar 100 mm outer. That means collar outer diameter is given 100 mm and 60 mm inner diameter. Values of coefficient of friction at the thread surface is given, that is 0.15, and at the collar surface is given at 0.12 respectively. The screw rotates at 30 rpm, and what you have to determine? Power required to drive the lead screw and efficiency of the screw. It's again the problem from V. Bandari's book. Okay, let us see how to solve it. Always read the problem statement carefully, and based on that, you can write down the given data. I am going to note down. It's a lead screw, single start, trapezoidal, nominal diameter D, 52, pitch 8 mm, and exert axial force W 2 kilonewton. Then thrust collar outer diameter 100, inner diameter 60, coefficient of friction for the thread surface 0.15, for the collar 12. So I have written all these dimensions. You can note down this problem statement. What you have to do? You can write down the given data. I am going to write down. Look at this. What is given? W is given 2 kilonewton. It is going to rotate 30 rpm. It's a trapezoidal thread. Again, for a trapezoidal, how much is the thread angle to theta? 30 degree. That's why theta is equal to 15. And it's a single start. Single starts meaning lead is equal to pitch. Lead is lead is equal to pitch. Pitch is given 8 mm. The lead is equal to 8 mm. Then for a screw, nominal diameter 52 mm. Mu is given coefficient of friction at thread surface 0.15. For collar, outer diameter 100 mm, inner diameter 60 mm, and mu c 0.12. Now let us see power required to drive the lead screw. It's very simple again. First of all, always find out the data, minimum data required to this. The dm is equal to, again this relation you know very well. We have already written, you can check position. The d is equal to 52. Is a 0.5 p, again applicable to trapezoidal, acme, square ones. Then 52 minus 0.5 into pitch, you will get 48. Then 10 alpha is equal to L upon pi dm. Dm is equal to 48. Lead is equal to 8. You will get the alpha. Okay. For 10 alpha I have written, you can find out the alpha helix angle. Then here it's a trapezoidal thread. For a trapezoidal, what you have to do? You have to replace mu by mu sec theta. And that's why I have written mu sec theta is equal to mu by cos theta. And what is theta here? 15 degree. I have substituted here. You will get mu sec theta is equal to 0.150. Why I have determined this? Because in the expression of torque required to raise the load, to lower the load, there is a mu sec theta, because I am going to use directly this relation. Okay. Now you know very well. Look, let us start. The first thing, for a trapezoidal thread, torque required to overcome the friction at the thread surface, this is 1. So what is the relation? Mt is equal to P into dm by 2. W dm by 2 into mu sec theta plus tan alpha upon 1 minus mu sec theta into tan alpha. That's why I have determined on earlier slide tan alpha and mu sec theta. You can substitute this value directly. Okay, after substituting this value, you will get, this is the torque required to raise the load at the thread surface. Then another case, torque required to overcome the collar friction. You can determine now. What is the relation? If it is not mentioned, always use the uniform wear theory. According to wear theory, mu c w by 4 do plus di. Do outer diameter of the collar 100, inner diameter 60. This is the 4, mu c is given 0.12 and w is equal to 2 kilonewton, means 2000 newton. So you will get this, and you can edit. You will get the total torque required to drive the lead screw. Therefore, MT is equal to MT plus MTC. This is the total torque. Once you know the total torque, what you have to do? We have to find out the power based on the total torque. And therefore, power is equal to 2 pi n into MT upon 16 to 10 raised to 6. MT is the total torque required to overcome the thread friction and the collar friction. N is given 30 RPM. You can substitute and solve it. You will get the kilowatt means power in kilowatt. You will get 0.0618 is the kilowatt power required. And then another one is the efficiency of the screw. It's very simple. In the earlier problem, first problem also we have determined the overall efficiency. The overall efficiency is equal to work output upon work input. Work output is equal to W into L, and MTT into 2 pi is the work input. You can substitute, you will get efficiency 12.90. So in this way, you can solve the problems. In this way, you can solve the problems. For this purpose, I have referred V.V. Bhandari's book. I have referred V.V. Bhandari's book.